Hello guys, welcome to this new session. We'll continue developing our end language. In this session we will do another optimization at the level of memories. So remember guys, this how we store values in our end language. So how we pack the data structure, the data types like boolean, number, nil and object. So this is the current version of our end language, how it stores data types like boolean, number, nil and object. So it stores it in 16 byte. The first 4 bytes is for the data byte, the data type, and the next 4 bytes for padding, and the last 8 bytes is for the payload or the data type, like boolean, number, nil and objects. So in the NaN Boxing we will use the floating point format. So as you see this, we have the first bit is the sign, and we have 11 bit for exponent, and the last is for the fraction part. So this format is on 8 bytes. So we will use something called NaN Boxing. So we will use that number. That is not a number. NaN Boxing is stand for not a number. We'll use this technique. So this is an example for not a number. So we will use this bytes to the payload to store boolean, number, nil and object, and it takes only 42 bits to store that, and the whole thing is on 8 byte. So as you see guys, there is much more difference between this current version and this future version. We will do it right now. This is represented on 16 byte and this is on just 8 byte. So it's the half of this current version. So let's imagine we have a memory. So in this version we will use it all of the memory, but in this version we will use the half of the memory. So this is a good optimization. So I will show you a resource from Wikipedia. So as you see, in computing, NaN stands for not a number, is a particular value of a numeric data type, often floating point number, which is undefined as a number such as the result of the division of 0 over 0, or systematic use of NaN was introduced by the IEEE standards. So this is the use of NaN. For example, if we have division 0 of 0 by the standard IEEE, we will raise an error that it's or we will return not a number. So guys, let's jump right to the code and we will implement this NaN Boxing optimization. So first of all, we will go to command.h and we'll add a macro to activate NaN Boxing, and we will go to value.h, and here I will just cut that over here. So what I need to do is to re-implement these macros for the new approach for NaN Boxing. So what I need to do is to do a macro if define NaN Boxing, then I will do this, and else if that macro is not defined, this it will be the case. So and and this for NaN Boxing macro. So let's go right here, and I will make a new type. Is the type value is int 64 value. Okay, the value will be represented only on 64-bit. So then I will define the NaN not a number, the NaN number. So I'll name it Q NaN, and it's a 64, and I will represent it on hex. So x 7 fc and zeros. So let's see how many zeros we have here. 1 2 3 4 5 6. So that's it. So let's define another macro. I will use it in case of objects. I will name it sign bit. The first bit is the sign bit. So I will just copy that, put it here, and it's 8. So that's good. So let's define, first of all we will start by implementing the macros for boolean values and for nil value, because they are the simplest one. So I need 3 more tags, this one, and the second one is tag false, and third one is tag true. This is the two last bits, and this is 0 1 0 and 1 1. So let's define, define false val, and false val, it will be this value, and I will cast that to 64, and I will do or bitwise between QNAN and tag false. So I will add that to that to represent a false value. So let's do it for true. So I need to just copy that line, and let's do it here. True, and I will use the true tag, and that's it. Let's also add the nil val, will use the tag null. So now let's make this macros. So what I need to do is to go after that, and remember guys, in our Ant language, the whole Ant language is it used these macros, so I need to re-implement it here, and then I will rebuild my project, and the run will be good. So I will implement the first one is boolval on some boolean, and what I need to do, okay, fine, boolval, and I will check that boolean, and if it is true I will return true val, and if false I will return false val. And okay, so let's make define as bool. I need to read that value as a boolean, so what I need to check is I will do value is the value equal to true val. So if the value is false, and false, remember guys, is the none plus the false one, so I will check if it is equal to true, and if false not equal to true, so it will return false, and if the value is the true value, then it will equal the true. So let's add the last one for bool, so is bool. Is that value a boolean or not? How we will know it is a boolean or not? I will just add 1 to the value. So I assume that the value is a false one, so I add 1 to it. So then I will check if it's equal to true val. Okay. Okay, so we finished by bool. So let's do the nil. So nil we will not use as nil, and I will do is nil. Fine, is nil. And to check if it is a nil, I will just do value is equal to 1 nil val. So far so good. So let's do the rest. So I will do the define number val, and we have a number, so I will use a function called number to value, and pass that number. So let's implement that function. static inline num to value, and we'll pass a double. Then we will make variable value, and we will use the mem copy on the value, and the source is the num and size of double, and we will return value, and that's it. So let's continue, and I will define the macro as number. I should read it as a number, so I will, what I need to do is value to number, because that argument passed to it is a number stored in the NaN and in that payload. So I need to make, no, excuse me, for in the case of number we will not store the payload in the NaN, so it's a special case. The only thing that we need to pack into that number is only false, true, only boolean and nils and pointers. So let's implement also the function from value to number, and I will pass the value. So let's static inline double value to number, and so double and copy, and I will copy to the okay, that's it. So let's implement the macros that check if it is a number. Is number value, and what we need to do is to do an AND with the NaN and check if it is not the same as QNAN. If I did the AND with that and check it is different than QNAN, this is mean a number. So let's take an example. If we have the true value, so remember that true value, it's the last bit, the last 2 bits, it has 1 1. So if I did that true value with AND with that, so this 0 will make the true values payload also always all zeros, and if I did different than QNAN, it's false because it is equal, and true value is not a number, it's a true value. So that's, it's working for numbers and it's not working for true false and nil and pointers. So that's good. Okay, so let's continue, and we will add also, we will define object var an object. So first of all I will cast that to a value, and I will sum up the sign bit and QNAN, because the sign, if the sign bit is 1, that's mean the number is actually a pointer. So that's why I did a macros separate from QNAN. So because when I need to check it, so how to how to know it's the pointer is packed into this payload by checking the sign of the first bit, and the sign of the array is 1. So that's it. I sum up the sign bit with Q9, and then I will also sum up the object, but the object should be casted into a unsigned int pointer. And then it will be casted to a unsigned int 64. So that's it. So this make a object. So what we did, we cast the object, and that we will add it to the payload of the NaN, and then we add all this and add to the first bit a sign bit to distinguish between a pointer from values and nil from false and true and nil. So that's good. So let's do the inverse operation, how to get that object. So define as object value. So what we need to do is really simple. I will cast the result to an object, and then I will cast it to an unsigned int pointer t, and then I will make a boolean a logical operation by doing AND on the not of the plus of sign bit and Q none, and that will get us the payload of the pointer. So we did that to remove the first part, to remove the part of the sign bit and the part of 7ff and c, and the rest will be our pointer. So that's it. So let's do the last one. We'll implement the macro is object value, and how we will check that is just by value and sign bit or QNN, and then we will check if they are equal with sign bit and QNN. So that's it. So that's it for NaN Boxing, and we will go to value.c, and we will change printing value and the function that tests the equality of two values. Why these versions are not working right now? Because in the NaN Boxing we don't have val number and these types, and what we need to do is if define NaN Boxing, I will do something else, and if also for this one, if diff NaN Boxing. If the macros doesn't exist, the old version will work, and if the user activate the NaN Boxing, the implementation of the NaN Boxing will work. So what we need to do here is just to check if is number value, and let's copy that. So else if is bool, I will print that. And else if is nil, I will printf nil, and else if is object, I will call the function print object. So that's it. So let's go for value equals. So I need to check if is number A and is number B, then I will do return as number A equal as number B, and otherwise I will just return A equal B to test if these two values are equal, because remember guys, these two values are just 64 bits with a bunch of numbers. So the only thing that I need to check if these two are numbers, then I will check. So otherwise, if it is holding true or false or nil, all different values, I will just check if they are equal on none, on not a number. So that's good. So let's rebuild the project and see if we have any issue. So we need to import that new copy. So let's go to value.h, and I will include string.h. So everything is good. So I will run cut the sample, and let's run our interpreter on that script. So as you see, we have the bytecode, and it will set in a value 10, and I will print that age, and I call this one so from superclass and this, and as you see, everything is good with the new approach of NaN Boxing. So the last thing I will do is to disable these debugging macros to see directly the result of the script without bytecode. So and that's it. The initializer is working, superclass initializer. We have the function call from superclass. So we called from superclass and we print the subinstance, then we return a superclass function, and then I will print the age, and then I will print the same. So that's it, guys. In this approach of NaN Boxing, it's a cost saving in the level of memory. We used now the half of the memory, so imagine we have a big program. So in the previous version, so I will name it not current, but now it's old version. So in the old version we use 2 times the space, but in the NaN Boxing approach we use only the half of the space, and that is a saving of our memories, and that also makes our interpreter run much more faster. So guys, see you in another session, and we will continue our journey later. So see you guys.